Thank you for joining. So welcome to today's virtual panel, Is Your Building Too Smart? Maximizing Impact Through Simplification. My name is Ian Firestone. I'm a direct digital control specialist with Chicago Public Schools. And today's program was put on by the Illinois Green Alliance Programs Committee, a volunteer group that coordinates educational events covering a wide range of topics throughout the year for the green building industry. The team that organized today's event consists of Mateos Arovosis, Jed Starner, and myself. You all have been muted upon entry, so please type any questions you have throughout the session into the Q&A, and we will get them answered at the end. The webinar is being recorded and will be sent out in a follow-up email. For those that are unfamiliar, the Illinois Green Alliance is a membership-driven nonprofit organization that advances green buildings and sustainable communities for all. Our 5-year strategic plan pushes the green building industry to meet or get on the path to net zero. We achieve this work through educational events like panels and building tours, by engaging communities and partnering with organizations across Illinois, and by advocating for new policies and legislation. Check out our website, illinoisgreenalliance.org, to view recordings of our past webinars, see upcoming events, learn about membership, and find ways to get involved. This webinar is approved through AIA for 1 LU credit and can be logged for 1 LEED AP or Green Associate CE hour. To request AIA CE credit or a personalized certificate of completion for architectural license CE reporting purposes, follow the QR code on the screen and complete the linked form. We'll also be linking the form in the chat now and at the end of the session. For those interested in self-reporting CE hours for your LEED AP or LEED Green Associate credentials, we will be sharing self-reporting instructions and a fillable certificate of completion in our follow-up email to all attendees next week. Here are today's AIA learning objectives. I also want to take a moment to recognize Illinois Green Alliance's sustaining sponsors who make our work possible. A special thank you to our gold level sponsors, ComEd, USGBC, and Sloan. You can visit our website sponsorship page to start a conversation about sponsorship today and make a commitment to advancing green buildings in communities across the state. I'd now like to introduce the moderator of today's panel, Elena Savona. Ms. Savona is a senior consultant with more than 22 years of experience in the energy and sustainability sectors. She is president and owner of ES Consulting, a Chicago-based firm that helps organizations design and implement sustainable solutions in the building industry through policy, programs, and development initiatives. Ms. Savona was recently recognized by Crane Chicago Business as one of 2024 notable leaders in sustainability. Prior to starting her own firm, she served as the Senior Director of Government Partnerships at Elevate, where she led strategic engagement with federal offices and was responsible for federal and public sector funding. Ms. Savona is actively involved in the green building industry and currently serves as treasurer on the board of directors of Illinois Green Alliance.
Hi, everyone. Thank you, Ian, for the introduction. And yeah, welcome everyone for to spend with us this hour on this webinar. Thanks to the programs committee again for putting together this session. So this session focuses on smart buildings, and we'll hear different point of views on how to really maximize smart buildings without overdoing it. I'm going to introduce our speakers and have a few questions for the panel, and we will also take questions from the audience. So feel free to add your questions in the Q&A function throughout the program, and then we'll get to those towards the end. Now let's introduce our speakers. So we have Frank Soldano. Hi, Frank. Frank is Vice President of Architecture and Planning at Related Midwest. Since joining Related Midwest over 30 years ago, Frank has served in both construction and architectural project management roles. He is responsible for technical coordination and quality control across a variety of new construction projects and helps establish and implement sustainability goals for all Related Midwest developments. A licensed architect and a LEED accredited professional, Frank completed both his undergraduate and graduate studies at the University of Illinois Urbana-Champaign, culminating in a master's degree in architecture and an MBA. Welcome, Frank.
Hello, everyone.
And next we have John Song. John is a seasoned leader with a passion for building infrastructure design, modernization, and system replacement. As Vice President at McGarry Engineers, he has played a critical role in guiding clients through complex capital projects, helping them navigate everything from MEP and fire protection design recommendations to and contract negotiations to long-term capital planning. His ability to bridge technical expertise with clear communication has made him a trusted advisor to building owners, architects, and facility managers. John's expertise spans a broad range of high-profile projects in commercial, institutional, and high-rise residential buildings. Welcome, John. And last but not least, we have Stephen Crow. Steve is a director of AI enablement at Jackson Control, translating a career that began on construction sites through building management, controls engineering, and data integration into practical strategies that turn facility data into measurable outcomes. Today, Stephen consults with Chicago Public Schools on district-wide operations and controls, while mentoring students through the nonprofit Stacks and Joules. Stephen also authors an AI enablement framework that guides organizations in adopting generative AI tools responsibly and effectively. Well, welcome everyone. As you can see, this is a really amazing panel with very smart people. So I'm very excited about moderating this session. And I'd like to start thanking all of you speakers for joining the panel and sharing your expertise with everybody else. I would like to start with a question for each of you. If you can quickly share your involvement with smart buildings and what that means to you. And maybe we can start with Frank and then John and Steve. Frank?
Yeah, thank you, Elena. As she mentioned in the description of my biography, I'm Vice President Related Midwest. We are part of the Related companies. We have a variety of projects across the country. My particular involvement, and Twyla, if you can move to the next slide, has primarily been in the work that we do here in Chicago. And what is a smart building from my perspective and my engagement in it. At the bottom right corner of your screen, you see a rendering of the newly announced Chicago Fire Stadium at our project called the 78. And so in the context of that project, a smart building isn't necessarily even a building. It's an urban environment. It's an active riverfront. It's a campus of buildings, and the smart technology that goes into that includes things that address parking management, traffic control, crowd management, public safety. So again, it's not always just an individual building. Again, my particular personal experience and the frame of reference I'm going to bring to the conversation today is based mostly on my work in the multifamily environment. The image on the left is an image of our 400 Lakeshore Drive project currently under construction, the North Tower, 72 stories, 635 units. It's a building with a lot of complexity to it. But the image on the upper right is a recently completed mid-rise 67 unit building at our Roosevelt Square development. Smaller in scale, but with a corresponding level of complexity. Certain systems in that building, integrate a lot of technology. If you could go to the next slide, how I see building technology kind of falls into three categories. Twyla, are you able to advance? Thank you. So that top row kind of, it represents to me sort of the typical usual things that I think a lot of people assume fall into the categories of building technology, building automation, lighting control, security and access control, elevator management, dispatching, things like that. And then a lot of metering and trending and reporting that is possible. But, more and more we're dealing with things that are related to indoor air quality or package management, EV charging, leak detection, entertainment, and streaming content sort of things. The bottom row really, kind of epitomizes kind of the last component of this smart building thing that again, is always a part of what we do and how we approach smart buildings. The icons on the far right and far left represent apps that we have created for residents and occupants of our building. There's a related Connect app for people who live in our residential buildings. There's a related Life 360 app for people who work in related commercial office buildings. And together, those apps let that resident or occupant experience do more with things such as scheduling services, arranging play dates for your dog, as an example, controlling, the smart thermostat within your dwelling unit, making reservations, whether it's for a space with an amenity space within a residential building, or at a restaurant that might be located in one of our commercial buildings. So that is kind of my perspective as a smart building, and kind of where a lot of the different technology that we're going to talk about today kind of intersects. I think we're going to move on to John now.
I don't have access to my video camera. There we go. While it's starting up, hi everybody. My name is John Song. I'm a team member here at McGuire Engineers. We are an MEP engineering firm, consulting specifying engineers. And our role, I'm here to discuss our role as MEP engineers in the smart building world and what that really means for us. Just starting off the definition of what a smart building means, it's the integration of using data to control just to control the operations of within a building, and like Frank said, or within a neighborhood potentially. We as MEP engineers need to, of course, discuss with the ownership team what their goals are for a quote unquote smart building, and work with everybody on the team to from the building engineer to the integrator to make sure that the systems that we are specifying are generally able to work with the integrator and what their goals are for a smart building, and our team's role in all that. Some of the big, I think, question marks that we usually run into is, what can we do with the systems we have? What can we do, or what equipment needs to be replaced? McGuire Engineers specifically, we are I'll call us specialists in the existing built environment. So a lot of existing buildings, repositioning, adaptive reuse, that sort of thing, or equipment replacement. So there are some questions that we receive from ownership about, hey, how can I make this smart, right? And again, our job is to translate what the ownership wants, and facilitate and keep moving along with the integration process. I've got a picture here that's, I'm sure everybody here has seen before, and there's definitely different variables of this graphic, but this is what I show all our young engineers when we come in, when that come into the industry. There's a lot of I'll call it discrepancy that can happen, or misunderstandings that can happen between what gets discussed at the beginning of the project for the goals, and then what eventually gets integrated and what the client ends up with. So it's a team effort, of course. So as much of a role that we have in specifying building operation systems, the BAS, we're actually kind of a small part. I see a lot of it's common in the data center world right now, where previously we would build the infrastructure for data centers, for example, and then IT would come in and fill up the racks. But now, just like that's being turned around, where the IT team now has a very integral part at the beginning, it's sort of flipped over, right? It starts off with IT, and then, the engineers and the construction team sort of try to build around what IT wants. And same with the smart building design. Previously, it's, hey, we will provide this infrastructure to control your systems, but now IT has to become involved, and we work around IT with their requirements to integrate. So a lot of interesting things here. Excited to be a part of this panel and hope to share some of my insights here.
I'm up next, John. And I really appreciate that picture and it preceding my my slide, especially with that tire swing at the end. So my name is Stephen Crow. I work for Jackson Control. We act as an MSI, which is effectively a master system integrator, and really trying to help provide the output that client is asking for by reviewing all the controls activities in around that request. Myself specifically, I happen to be the one that, if we're looking at those 3 images in the last slide, I'm the one that has to work with the operator that thought they were getting a wooden swing and wind up with a tire swing. And I'm the one that usually has to go in and say, yep, you should have had that wooden swing seat, but you don't. And I know nobody ever taught you how to push somebody and set somebody up in a tire swing, but here's how you can do that. And then I'll go back and talk to their leadership and say, putting in this tire swing may have been a mistake. I know that they really wanted it, but to source another tire for this tire swing, it's going to take us 2.5 years and cost us 5 times the amount of what it would if we would have stuck with that wooden seat. And where this experience comes from is, unlike most of my colleagues on this call, I don't have a college degree. I made some poor decisions at the end of my high school career, which I think a lot of us do, which led me into the construction world. Which in the past I was a little ashamed of, but now I'm very proud of, because I was able to create my career around kind of real world field experience. So I've had a lot of hands-on activity, a lot of hands-on time kind of working at that bottom layer. That eventually led me into building and property management, which eventually led into commercial building management, which of all things eventually led me into building automation system integration, where I learned a lot about the data flow within buildings and how to try and be more strategic about it. I spent a lot of time also learning that data and that strategy was not realistic for 90% of the organizations that I worked with without things being incredibly simplistic. I have spent a lot of time learning about workflow and how to try and ensure that things will actually continue on because they fit within an existing workflow and are not making a complete change that everybody else within the organization is not able to really do. And where I talk about in the next image there on from data to action, I think a big misnomer in this process is that these things need to take a long time and be incredibly complex. But when it comes down to it, when we're talking about operational data or any data point, there's kind of 4 steps. You have to pull the data, map the data, clean or make sure the data is clean, and then act on that data. The complexity and the stuff that comes in between there is stuff that is created by typically a misunderstanding from the first couple of steps on what devices and things integrate together and stuff like that. And then in that last image, kind of around that my belief, it's the simple data stories, that it's nice to have 50 different data points to help us understand what's going on with all these different components. But if we can only act on 2 of them, then we probably only need to really care about those 2. And another kind of core belief I have around all of this stuff and with smart buildings is that even the term smart in smart buildings it's a lazy term. And I'm guilty of it. I use it all the time. It's in one of my previous titles, where it creates this expectation that everybody knows what you're talking about. And it also creates an environment where nobody really wants to say, what are you talking about? Because as Frank was showing, a smart building for an architect is going to be much more based around client experience than it is for an operator, which is going to be much more around operational value than it is to an owner, which is going to be much more around cost efficiency and effectiveness. So I think a lot of what we're going to talk about today is how do we get more deeply specific on what smart means to us and what goals we're trying to achieve through it. So I think that pretty well wraps up my bit for this slide.
Well, that's great. And that opens to our conversation part. I'm very excited about this. And I'd like to start with talking about goals. So Frank, you and both Frank and John and you, Stephen, also touched on that it sounds like goals are, the owner's goals are really important. And determining that is very critical across the process from design to operations. So maybe Frank, if you can comment a little bit on how smart building goals are typically defined in your projects and share that with us.
Sure. Kind of fundamentally, the goals and the way we define them kind of fall into two categories. The question of why are we choosing or evaluating or considering a particular technology? And then also the why not question is like, what are the reasons that we might want to not incorporate something or choose a particular way to do that? On the why side, in a very literal sense, we ultimately want to make our buildings operate efficiently. And again, at that very literal sense, efficiently means, what a lot of people would be thinking about in terms of, I'm using as little energy as possible. I'm paying as little as I need to for gas, water, electricity. I'm generating as little carbon and having a small carbon footprint as possible, because that may be a goal, that may be a reason that I need to fulfill a sustainability commitment or an ESG promise. So those are some of the kind of really tangible goals, but I think about building efficiency also in terms of the people who inherit what somebody like John designs and something that Steve implements. It's those building engineers, those property managers who work, with the technology that we give them. And if it's appropriate and if it's considered thoughtfully, then they are able to work more efficiently. They're able to address problems. They're able to address occupant concerns. They're able to preserve the value of things that we've built in the building because they can be more proactive in terms of preventive maintenance and things like that. And when things aren't working right, they're able to hone in on what needs to be fixed, what needs to be repaired, what's not working right. That why question, that what are we choosing, how do we choose what to incorporate, what not, kind of falls into the same sort of a decision matrix that a lot of other things do, like in an amenity context, do I want a pickleball court or a golf simulator in our building, or do we want black appliances or stainless steel appliances within a dwelling unit? All of those sorts of decisions kind of fall under a matrix that is kind of fundamentally, will somebody want to choose to live or work in a related property as compared to a competitor's property? Do any of these decisions that we make contribute to that? And once that person or that organization has made that commitment to that related property, are they going to stay? Or is their experience and how the technology enhances their experience? Does it let them, does it encourage them to stay longer? The why not part of that, real quickly, it falls into kind of two different things. I spend a lot of time dealing with security concerns. We gather a lot of data. We have a lot of components within our buildings that have internet IP access, and so there's always a lot of concern about, again, not only that data privacy, but also that vulnerability to outside actors. Kind of one of the personal metrics that I use as I'm looking at technology, I'm asking the question, is this a solution to a problem I don't really have? And so, the anecdotal example of that is, a while ago, there was somebody who was pitching an appliance, a washing machine. And it was like, hey, we can set up your washing machine so that every time you do a load of laundry, it makes a charitable contribution to a charity of your choice, and so all of a sudden it's like, do I really want Whirlpool to have my credit card number? Like, and again, is that do I need to just, I want to keep my laundry needs separate from, my charitable giving. And so, again, is that was a technology that, didn't really, have an appropriate place, in my opinion. But, using that metric kind of helps us evaluate, what, things that are not necessarily our goals.
Right. Yeah, that's a good point. It sounds like a smart building is truly smart if it meets those owners' requirements and what they really need, those goals. I'm curious to hear, John, from your perspective as the design, representing the design there, how do you take these owners' goals and make sure that they translate during the design process? And maybe if you could share if you have some examples of maybe major pitfalls that you see or you have seen in your experience.
Sure. So I'll start off by saying that, I've been trained by some really great engineers, and what they always told me is the engineering is the easiest part. It's the communication with the client, understanding what they want, interpreting what they want correctly. That's the more difficult part. And then as engineers, we love to just maybe, hit our Excel spreadsheets and do a bunch of calculations or draw a bunch of stuff up. But really, it starts with understanding what Frank's goals are for his building and what he really wants to do. What is the ultimate end goal, right? Because he could be giving me a bunch of details, and I have to interpret that correctly, and coordinate with him on what that really means. Um, and we have to do it smartly, right? We have to do it with intent for future proofing. We have to do it with an understanding of, hey, this is day one, right? And we want this to happen in day one, but day end, who knows, right? Because the world is evolving. I mentioned data centers before, and data centers, they use the density of data racks used to be quite low compared to what they are today. And it's wild how much that's changed. And with the, AI and chat GPT and supercomputing and everything, a lot of that stuff, there's a lot going on, right? And I'll leave it at that. And it, to set yourself up for success for the future, it requires some thought, right? And so going along with Frank's laundry machine example, there's a lot of times where engineers and architects may not necessarily think through future proofing, right? They may have a great option for this toilet, right? This toilet's awesome. It can self-clean, it can do this, it can do that. But then, if you're looking at that toilet, maybe it's something where the tank is inside the wall, and it's great, it looks great, it does everything you want, but then, if it leaks, are you gonna know it's leaking? Probably not until it becomes a big issue, right? Or unless you have leak detection and all that kind of stuff. But we have to do things and put some thought into it to make sure that we're not setting up ourselves for failure or turning over a building that Frank, maybe it works day one, but then day two even something breaks and all of a sudden everything goes to to crap, if you will. But no two clients are the same. I think we all know that. Everybody in this industry, every client has, they have a variety of goals that they want for their building. They have a bunch of different budget constraints, and or just different physical limitations. With the smart building design, right? At the very beginning, how we define it is data analytics, right? It's the marriage between data analytics and building operations. And so the cost of maintaining all that data is quite expensive, right? And so if that doesn't work with with Frank's budget, that's can't really do much there. There's this whole thing of about being reactive versus being proactive, and I think smart buildings are right. We're trying to trend towards being proactive, but maybe being reactive is okay. It's going to be more cost prohibitive to go with the proactive design. But then if we're reactive, maybe it saves money and still accomplishes the goal that Frank has. For example, do you like just taking a commercial office building, Frank may have a situation where, okay, as soon as people walk in, I want everything to turn on and I want, maybe they have an elevator card and, an entry card or security badge and they hit that. Okay. So then that knows that, turn this office on. Right. And And maybe that's great, but do you really want your HVAC system to start operating when one person enters, or would you rather have it just on a schedule, which is much easier, right? Because if someone comes in at 4 in the morning, well, that's potentially 3 hours of additional energy usage that, for one person, which may not make sense.
Yeah.
Or, does Frank just want to know, or his operations team just want to know, hey, I just want to know if this unit's going to fail, right? We put a lot of ECM fans. And anybody that's been in the world of having to replace those or having to order those knows that there's a long lead time, right? But it would be beneficial to know, hey, I think this is gonna break down in a couple months. Hey, you should probably order your equipment now. There's a lot of interesting things that manufacturers are doing to provide solutions for that. Whether it's measuring the vibration and knowing that your motor windings are starting to go. And then finally, in terms of what a smart building means, right? And for lack of a better term, protecting the clients from maybe what they don't know, I'll just leave you with this, is that buildings from 1970s and 1980s are, and before I shoot, probably shooting myself in the foot here, but they could potentially be more efficient than the buildings nowadays, right? And yeah, they had higher lighting loads and all that kind of stuff, but to turn that building off, just turn off the compressor. Where now, you could have a computer running it, and the computer or the AI or whoever's doing that stuff may incorrectly interpret something and turn your building system on at 2 a.m., right? So there's a lot of things that is important to think about in implementing the owner's goal, and really trying to translate it correctly and coordinate with them on what their ultimate goal is.
Yeah, it sounds like there's a lot of choices that you can make, and a lot of decisions that you make at the design stage that are really critical, both to meet those goals from Frank's goals, or that they may have an impact on the operations. And so maybe Steve, if you can jump in and talk a little bit more about how you see those translating into operations, and what are the challenges maybe, and the successes that you see.
I think the biggest challenge is that the way the operators feel, and this is through just practical time and experience, is that they're the victims of dealing with the theory. That a lot of times, and oftentimes, there is theoretical, hey, this is theoretically going to save energy. Hey, this is going to theoretically make your life easier. This is going to theoretically do this. And that gets implemented because it's a very exciting, cool looking opportunity that was sold very well, and, told this owner, hey, you can go from, whatever EUI all the way down to this if you implement all these technologies and all these strategies. And then it gets handed over to that operator. And the operators typically care about one thing, that building engineer, and that's keeping the phone from ringing with complaints. It's going to have nothing to do with maximizing energy savings, and that's not what the owner is paying that building engineer to do. The owner doesn't want to hear complaints either. And so when an operator gets a brand new system installed that has all these different reset strategies and all these crazy ways that it's delivering air and temperature, and they can't figure out how to either give more air or more or less temperature, that's part of the problem. So there's a lot of those scenarios. And on top of that, even throughout the kind of structure of it, what motivates each individual member creates kind of roadblocks for the others, where if it were up to every operator I've ever worked with, we would have a bunch of Soviet era looking buildings where everything was pure concrete with small windows, because we can keep those things so controlled, humidity, temperature, airflow, all that stuff. And in their minds, it's like, well, who cares about experience? You want your temperature, you want your air changes, you want IAQ. But then if as an architect, you walked in there, or Frank, if you walked into a building and they were showing it off and showing your team, and it was like, look at this, you get so little daylight. There is no like cool water features that everybody likes to see. It's really this kind of at odds of client experience versus mechanical and building operations. And where it gets even more challenging is with that term smart, because again, that means something totally different to everybody. And it's a really almost an easy button to be able to say smart, instead of going through Frank's list of applications and saying, I want this, I want this, I want this, then going to John and saying, I want this, I want this, I want this at this cost. And then John saying, well, that cost isn't possible. You need to eliminate 2 or 3 of those items. But those conversations don't happen at once today. they happen in series. It's owners get sold on a big idea that they think is very cool, present that to the architectural firm who designs it, engineering firm takes it, has a bunch of problems, brings it back, value engineering begins, and that final product is that tire swing where they were expecting that platform swing. So it's a big lift to get to a point where the operation side is going to have more buy-in around this adoption of these technologies. And in a quick example, energy recovery wheels are probably a great thing when they're able to be maintained properly. But we have a situation in Chicago where it's $7,000 for a replacement belt. Well, do you know how much kWh it would have to save with an energy recovery wheel to equate that $7,000 on one repair? So, if we're looking at it from a cost standpoint, yeah, that's great at year 2, year 3. But if you're going to be owning portfolio buildings for 10, 15, 20 years, it's very different considerations.
Thank you. Yeah, it sounds like there are many decisions throughout the process. So I would like to go back to Frank. Maybe you can share from where you're coming from and what challenges do you see in this design process of a building, and what would be an ideal process to you?
Yeah, and I think I want to answer your second question first, because from my perspective, part of that ideal design process is really implementing that feedback loop, and being able to take lessons learned from previous projects or from previous experiences that other people might have had. Anecdotally, we have a project that we did a while ago and incorporated a very elaborate lighting control system, and the property manager came back and said, that's great, I have these daytime scenes, dusk scenes, evening scenes, and it all just works off a clock and it changes automatically, but what I really want is a button I can push to turn everything on so that the housekeeping staff can do their work. Excuse me. I had a similar incident with a building engineer who came to me at some point after we turned the building over and said, I'm getting these texts in the middle of the night because the garage exhaust fan is running. It's running just fine. It's operating exactly the way it was supposed to, but somewhere in a specification there was some kind of a status notification that got built into a BMS system, and this poor guy, like I said, was getting woken up in the middle of the night. So it's that sort of feedback, those lessons learned that you kind of turn into the next building at the beginning of that design process, and you pay more attention to, and you hopefully build a better. I always like to say, I'm going to build a better mousetrap the next time we start building a mousetrap.
Frank, to that point, I did want to ask you a question about that, because one of the things that I think I wonder about from your perspective is, do you think that finding quality partners is an important part of that? Because I'm a big proponent of be willing to admit what you don't know, even though that can be challenging in certain environments. Do you find that you get value out of partnering with trusted, whether it's contractors or advisors that you kind of stick with?
Yeah, definitely. We definitely benefit from, the ability to work, consistently with design consultants, because they tend to kind of, again, learn along, they're kind of climbing that sort of learning curve. What is the related way of doing things, or the related standards, or the related goals. And the same happens with contractors. But, that's a luxury that not every owner has. We are constantly in the process of, building buildings, designing new buildings, versus, some owners may do this once every 10 years. It's like, hey, I'm building a church, or I'm building an addition onto my factory or something like that. And that is one of the challenges that, Elena also asked about, and it is that the reluctance, I guess maybe is the right word, or the deference to, when, business as usual or best practices, and not necessarily challenging, from an owner perspective, not necessarily challenging a design consultant to ask why are we doing this, Why are you incorporating this into our project scope? And the same comes from the engineer. It's like, why, asking the owner, why do you want this, or how do you feel about this, as opposed to just kind of saying, this is the way we've always done it in the past, and we think it works, and we're going to just kind of take our boilerplate specifications and move forward. So, at some point you kind of need to step back and kind of have those, that real frank exchange. And if you have the luxury of being able to have a similar conversation with an integrator, and if you're able to bring somebody on board to a project sooner, and you can start to say, hey, this is what I'm seeing on paper in a drawing or a piece of equipment specification. How do you interpret that? What does that mean to you? And again, ultimately, one of those other challenges is always, there is no unlimited bucket of money. You always have it's a limited resource, and you have to kind of deploy it the most effectively. And that is a really, kind of a challenging thing to do, because when we think about the technology components of all of these individual things that go into a building, they're buried a lot of times. It's like, the technology in a boiler, and what sort of data, what sort of information, what makes a boiler smart is buried somewhere, in that boiler specification. And it's not everybody, not everybody has the bandwidth really to kind of look at that. And then it's, a year later, 2 years later, and the integrator is coming back and saying, hey, I've got like 30 pieces of information for this boiler. What needs to be in your BMS system? What do you really want to tell your operator, your engineer? And honestly, oftentimes the simple answer, and kind of keeping to this concept of simplicity, the simple answer is, I really want the engineer to know something's not working. I don't need them to look at a screen to know it's not working. I just need them to get an alarm that says, boiler not working. Get your butt up to the mechanical room and go look at it.
Frank, where I think it gets even more difficult, and why it requires so many of these questions that you're talking about, is you're not going to know if you don't know. And it takes experience in the field and in the real world to kind of share that with the owner or with the builder or whomever. One of the things I bring up as a recent example is I was working with a building where there was a fire. And in the past, this building had been set up with IAQ monitoring, really to provide healthy levels of, indoor air quality, reduce CO2, all that stuff. But they were actually able to use this IAQ data as almost an insurance, where when there were complaints coming from tenants after this fire, they were able to use the IAQ data that was never set up to help with insurance claims or lawsuits to defend this idea that there were no more particulates in the air when they allowed that building to be reoccupied. And whether it's asking the question of the owner of, do you face a lot of slip and fall issues that you have to pay out for? Do you have a lot of security concerns? Because they're not going to be aware that there's solutions out there for those things. Whether it's leak detection, but that's a cost example, right? Are you paying enough for leaks and floods to where it would necessitate or validate the use of this, smart metering to stop that? And without having people on your team or within your group that have seen these things, it's impossible to get those questions kind of out through just, that theoretical application. It really just comes from real world use.
Yeah.
And both you, Frank, and Steve, your question there, you asked something about having the right partners to work with. And obviously, Frank has a very good experience with partners that they use all the time. I wonder, John, because you probably work with or pull together all the partners to work on the design of different components, right? So what is your experience there, and how do you find really the right partners that then provide a real solution to the
Sure.
not the problem, but what the goal we want to reach?
Yeah, like Frank said, communication is key, right? Having good partners who will speak up if there's something wrong or they see an issue, regardless of who whose contract everybody's under, right? That's very important, especially in the construction industry, right? Where, you know, the temperature controls contractors are they're a very important part of this, right? Because they're the ones bringing in or they're the ones amassing that data, right? Or at least providing the sensors for then Steven or whoever to integrate all that stuff. And so if you look at temperature controls contractors, you know, a lot of times they're under the mechanical contractor who's under the GC, who, you know, and then you have us, the MEP consultants who are under the architects most of the time, right? And then, you know, so there's this siloed approach that was traditionally used in building design. You can't do that anymore. It's almost like a, what do you call it, the integrated project delivery method. You know,
John, there's something
everybody's
that
got
I
to be
think
speaking
that
together.
there's something that I think you would uniquely see in the engineering portion that I also kind of see at the end of the line. Do you also notice, because how would you ever know to ask this question, the difference between a temperature control contractor that has networking and IT experience versus somebody that's just been able to kind of put controls on a wall? I don't know if you can speak to that at
Yeah,
all.
yeah. I mean, you know, controls contractors. Here's the other thing, right? Controls contractors they're not engineers. So, and you know, I'm sure everybody here has maybe heard of it or at least seen ASHRAE guideline 36. You know, I'd be curious to see how many people have actually implemented that. If everybody's ever read that, I think it's very complicated. And expecting a TC to understand that or why we do that is you know, can become an issue. So yeah, I mean, you know, again, they're not engineers, right? They don't understand how building systems necessarily work, but they can put all the controls together. They can put all the wiring from point A to point B. They know how to, you know, read this card and bring in the card, you know, information from there. But like, yeah, like you said, AVIT, you know, there's a certain portion where I think that they need to know how to connect them all. But you know, even AVIT is a separate group,
That
right?
yeah,
So
that's what as you were saying that,
they
John,
all
it
have to
made me think
talk.
we haven't even hit that yet, right? That we didn't even talk about how you have to get your IT team involved on the
Mhm.
front at the beginning, so that way you're not having an implementation done, and then at the 11th hour, a TC is calling the IT group saying, "Turn off this firewall so I can make this work," and the IT security group is saying, "What? We
No
don't do
way.
that. You got to send us a plan and networking diagram and all that stuff."
Right.
Yeah, so John and Steve, I want to know how you work together. And maybe John from your design, translate the whole
Mhm.
design and make sure that then the operations doesn't have that 11 p.m.
Yeah.
call or even worse.
Yeah, you know, again, the whole smart building idea, the way I define smart building is using data, right? You use the data, you use all the information and you know, like ChatGPT does when they scour the internet for all this information, right? Something has to happen, some calculations have to happen, something has to happen where, you know, A happens, so B has to happen and all that kind of stuff. So there's a lot of programming in there.
And John, you might
In
not know this, but the operators really rely on you guys, the and gals, as the engineering firm, because the
Mhm.
operators will see something wrong. And then if they run into an engineering firm that
Steve,
cares and that pays attention to what engineering team can then translate it into the proper speak, where the operators will often be told, "Oh no, don't worry about that. Oh no, that's fine. Oh, don't worry about that." But when they can get the weight of the engineer behind that conversation,
Mhm.
it's a major ally. Because
Yeah,
of
and
themselves, they can't speak the language.
yeah, and you know, case in point, right? It's important to have the team, right? All present, all understanding of what Frank wants in this case, right? Or whoever wants, whatever owner wants. Because yeah, like Steven, you know, right, there's a coordination effort. What do you need, right? What do you need to do to implement what Frank wants? Oh, you need outside air temperature, you need, you know, whatever, right? And then it's our job as an engineer to put the specs together to be able to obtain that data so that Steve and his crew can do their thing so that, you know, we can implement everything that we want for Frank.
yeah. There's a question from Sean. John, if you can elaborate on the IPD, the integrated project delivery approach.
Mhm.
It seems like IPD is a good strategy given owners who want defined budgets before scope is clearly defined.
Yeah, so let me preface this by saying that I've never been part of an IPD process before. I understand theoretically how it works, but you know, the person who's asking the question may have more experience than me, but the IPD it's the team, right? It's the project team from owner, architect, contractors. They all are part of the same team, right? And they all share. I think traditionally the IPD approach has been, everybody sort of opens their books up to each other so that we all know what's going on. And at the end of the day, if we can all save money, there's a pot of money that we can all split, right? And so, I'm not using that example to talk about contracts necessarily, but in terms of, hey, everybody has a part in this, right? If I fail, everybody fails. If Steven fails, I fail, right? It's a whole team approach, and you cannot get away from that team approach when you're doing something like this.
Yeah, thank you.
John, in converse to that, would you say that the lowest bidder approach to projects is like almost one of the worst ways you can do it to get a solid delivery on the smart building out?
Yeah, it depends, right? Because the lowest bid, yeah, traditionally in the sense the lowest bid is the lowest bid for a reason because they want to hold themselves to their contract and all that kind of stuff, right? But if you put it together, if you put the correct RFP together and get the correct information you want, and then Frank, I'm sure doesn't have just one contractor he usually goes to. He's probably got multiple that can all do the same work, right? And so the lowest bid is not necessarily the correct approach. It may not be the correct approach, but if you have good consultants, if you have good contractors, if you have good team, maybe that might not matter. But traditionally speaking, if we all think about the lowest bid, yes, in that regard, it probably is not the right answer.
Yeah.
And I think the other way to get there, but it's difficult, is you'd have to educate the heck out of yourself as an owner. You would have to really learn everything about this kind of industry in this space to be able to make all these decisions and choices on your own. So if you don't have the time and the ability to do that, you have to work with people that have already done that.
Yeah, sometimes it's really hard to.
And I wanted to kind of chime in on the question about the integrated project delivery and what it looks like, and the comment that John made about, well, who's the low bidder and what are you getting with that, and part of the challenge, both in the context of a mechanical control system and where that technology is, or in the context of a security or access control system. Oftentimes when, as an owner, when we're going through this process, we don't necessarily have that direct path to that vendor. We're hiring a mechanical contractor, and then that mechanical contractor, might just be saying, I've got an allowance for a temp control vendor, and, you give me the job and I'll bring them on. Right. Or, same with sometimes an electrical contractor will own that technology and access control scope. And so it's like you don't necessarily always have that ability to vet those people out, vet those partners out, and kind of understand. But eventually you do. Eventually all those people are coming to the table, and the sooner you bring them to the table and start, kind of going back and saying, hey, this is our goal. This is how it looked in the drawings and specs. How did you interpret it? Or, the other thing that happens is, hey, I've got a budget bust, and I need to figure out what I can change in order to meet, my budget goal, and what can I sacrifice and what really shouldn't I sacrifice? And that is part of that IDP process, I see it as. But as an owner, you really have to be committed to gather that information, and sometimes that doesn't happen. You don't have the bandwidth, you don't have the time, or and I don't know a lot about a public process, but sometimes you don't necessarily have that luxury of being able to dig that deep into some of those things.
I can see there's a question from the audience.
Be a John answer. It's a loaded question for you, John.
And John,
I did see that come through. Yeah, so I'm
okay.
sorry, go ahead, Elena, if you want to repeat the question.
I just wanted to reiterate the question. Boilers as an example, a lot of equipment have smart controls. How do you feel about allowing a boiler system for example, to operate under its own control scheme and just sending an alarm to the BAS instead of having the BAS manage the whole process there?
Yeah, so let
Depends.
me answer this outside the aspect of a smart building, right? Because I mean, it could change again depending on what the ultimate goal is. But generally speaking, I personally like to have the boiler system operate under its own controls because it's designed to do that. It's meant to do that. It's programmed at the factory for the most part. It's, all the controls are part of that, system that has been designed at the factory to integrate, to work with that specific piece of equipment. The issue is, in the construction process, and maybe Frank can attest to this, but in the construction process, the temperature controls contractors are typically last in, right? Because as we all know, construction typically likes to get pushed back, right, from the original date. And so the less and also to mention that temperature controls contractors, again, they're not engineers, right? And so for them to have to try to interpret maybe what I'm trying to have happen, they may interpret it incorrectly, right? And then you're relying on the temperature controls contractor to program everything correctly. Whereas, from the factory, you can have that all pre-programmed. Hopefully that answers the question.
And John, if you don't mind me adding to it a little bit, I think where it can be a benefit is when you're dealing with a critical system like your boiler system that would cause massive damage if it completely failed. If you had a networking error with your BAS or something like that, this kind of avoids that as being a issue that would cause a critical failure or an emergency because that controller would still operate independently. The scenarios where I find that to be a little bit of a problem when I've run into is if the controller selected by the team cannot manage the sequence that's required by specification. So if you have different specifications or requirements of your sequences, you have to look into those. And again, it takes somebody that understands to kind of look together, look at all the equipment and say, yes, these controllers, these boilers can achieve this specification or no. Because we do see a lot of times where full installations happen and then it's, well, this equipment could never meet the specification. It just doesn't work.
Great. I wanted to give the opportunity to ask more questions, to hear more questions from the audience. And I think there's one in the chat. I don't know if, John, you have seen that. Specific on the boiler system. And if anybody in the audience has questions for the panelists, please add them to the Q&A function. So
yeah, I'm sorry. Yeah, it wasn't necessarily a question, but I can expand on that. Correct. Yeah, if it's relatively simple, I mean, I would, depending on what you want to do, boilers these days are basically computers, right? And so there's a lot of complications there, but a lot of programming. So, I think the boiler controllers can do, yes, if it's simple operations, you tend to want to rely on those boiler controllers, but I mean, they're getting a little bit more complicated. They're becoming more and more like computers that just have to have, that happen to have this boiler component to it. But yeah, I'm not sure there's a question in there, but happy to answer if there is.
Great. For any additional questions, they can reach out to you all because everybody's going to have your contact information back. And I think we're at time. So I just want to thank everyone. And it sounds like smart buildings, yes, it's a great thing, but we need to really point to what we're trying to achieve without overdoing it. And I'm going to turn it over to Twyla to close out the session. Thank you so much for your participation.
Thank you, everyone.
Thank you, Elena.
Yeah, thank you, speakers. Thank you, Elena, for moderating. And thank you, audience, for watching. And we'll be sending you all a recording of this panel in a follow-up email. And we did put a feedback survey link in the chat if you're able to take a minute to share some feedback with us. And also use that AIA link if you want to report for AIA. This is the time to do it. We won't be able to take requests after the live session. So thank you all for joining us, and we hope to see you at another event soon. Thank you, speakers. Have a great day, everybody.
Bye, everyone.